In this video we'll show you how we can machine the handle from a DXF file. So I've started the CAD system, which is the best place to start when you're importing DXF files. So import the DXF file, which is this one here, and we're in millimeters. Okay, so that's the file. A couple of things we should do with that. Firstly is that we only need to have a profile which is either above or below the center line. So to do that, if I create a line and use near snap to snap onto the datum position there, then I can use intersect with split to split that arc where it hits the line and split that arc where it hits the line. And now I can create the profile which we use to take through into the turning software. So to do that, we use the NC button here, so we can see where the default datum position is from the DXF file, but we need to move that, so we use the set NC datum command here, and then we'll set our NC datum there, so that becomes ZX0. So now we'll produce a profile which will start at this end here. I can leave the defaults as they are, but it needs to know where the end point is, which will be this position here. So that has created that as a profile. So we save that away. And then we can take that through into the machining module. So because it's a new job, we can check our tool change position. So if we're using a front or a rear turret, then we can set up the home position here. So what we need to do is to define a tool. So we use the bottom toolbar here. So we can use a button tool to machine most of that, and set the tip radius and the Z and X offsets, and then the tool can approach from the rear, and it's probably mounted on a rear turret. So now we can select that tool for use, set the spindle speed and the feed rates. So we can use feed per minute or feed per rev, and if we want the coolant to be switched on, we use that here. So now we can do a facing operation or a turning operation for roughing out. So we use the turn macro. So this is defining a rectangle which will be where the tool will move between. So we probably want to start off here. So that's the top right corner of the rectangle, and the bottom left corner will be here. I won't go right to the end because I might need to do that in a separate op. So it's going to be limited to the part profile. If we want to, we can leave a finishing allowance in X and Y, and we can set up our cut depth. So that machines that out. As you can see, this is the center line of the tool. So if we run that tool, we can see the tool moving right the way over that shape. We can do a similar operation now using here, so we can cut round to the end. So we might want to use a facing operation. So we can start somewhere here and finish about there. So I won't go right down to the center line, otherwise we won't have a chance to do a finishing operation on that. Okay, so that's just machined round there. So that's got that part. Now we can use a profiling operation to take off any finishing allowance that we've left on. What we could also do is the tool, when it's finished this last part here, will end up here, so we can drive the tool to a safety position over here. So we can move the tool up to here first of all, use rapid, and then we can send the tool back to this position over here, again at rapid. So that moves the tool clear of the job, so that if we're using the same tool for the roughing and finishing, then in the profile operation the tool will be over here, so that it can machine all the way around there. So we use the profile turning operation, and I'll leave all the the options as I need them to be, and if we just click OK, right, so that's produced a finishing operation with an arc approach going all the way around here and then round to the end. So let's just save that file away, and now we could post-process that, or we could take that through into the 3D simulator. So if we run the simulator, we're running a lathe, so that calls up the simulator and it passes the data through to it. So we can leave all of these defaults as they are, just click simulate. So the bar stock that you see loaded here will be just created from the extent of the toolpath. So we can see the button tool there and the video controls at the top here. And we can control the speed of this simulation. Okay, so that's machined that. Obviously we need to do something a little bit extra on the end there, so that it doesn't foul the tool when it's machining that last part. So that's the main part of the program, post-processing that. This is for a FANUC control, and it produces the G-code file here, and so that's the file that's produced. So you can send that through to the machine tool. So that's that.